Hi, I am Dr. Eli Kolberg from Unlimited Robotics, and in this video I will talk about capacitor part 3. When a capacitor is connected to a DC circuit, it is charged up to a value close to the voltage of the source. It prevents a flow of current through it because of the insulating dielectric material that is positioned between the two plates of the capacitor. On the other hand, when the capacitor is connected to an AC circuit, the current flows through the capacitor with low impedance or with no impedance at all. Capacitors that has no polarity has usually values that are less than 1 microfarad. Capacitor that has polarity, meaning electrolyte capacitors, has usually values that are bigger than 1 microfarad. When a DC source is attached to a capacitor, a positive charge is accumulated on one plate and negative charge is accumulated in the other plate. The number of positive and negative charges is equal. It stems from the fact that for each charge that arrives to one plate, a charge with the same sign will be ejected from the other plate. That creates a potential difference between the plates as presented in the next figure. When the current and voltage attached to the capacitor vary with time, we get I of t equals dq over dt. dq meaning a small difference of charge and small difference in time duration, where it is the current in amperes, q is the charge in coulomb, and t is the time in seconds. Assuming that the capacitor's capacitance does not change, we get q of t equals c times v of t, where q of t is the charge in coulomb, c is the capacitance in farad, and v of t is the potential difference in volts. From last two equations, we get I of t equals dq over dt, which is equals to c times dv over dt. Extracting vt from last equation, we get vt equals v of 0 plus 1 over c times the integral between 0 to t of I of t tag dt tag. It means that when a varying voltage is attached to a capacitor, then in addition to the potential difference that is already stored in the capacitor, in time t, the added voltage of the capacitor equals to the accumulated current over time divided by the capacitance C. Next figure presents capacitor symbols. See that capacitor with no polarity is symbolized by two straight lines with no polarity sign. The other three symbols on the right are symbols of electrolyte capacitor. In an electrolyte capacitor, the sign plus will appear on one of the plates. The non-electrolyte capacitor is marked by two straight lines with no plus sign. One symbol of electrolyte capacitors is made by two lines, one straight line and one curved line with no plus sign. The standard is that the straight line plate is the positive plate with the sign plus. Thank you for being with me in this one. Hope to see you on next one. Bye bye.